Welcome to Impossibility Space, the second audio issue of the Shape Journal. In this edition, we examine approaching the levels of reality as a possibility space rather than a physical one. The issue is called Impossibility Space not because what we're discussing is impossible, but because when a new level emerges, it's impossible to predict what it will be from prior levels. The new level then alters its environment, including the creation of new, lower, subordinate levels. This is a problem for science, as prediction is basically seen as proof. So how do we address the unpredictable? How are these impossible spaces possible? At the moment, this is more of a provocation than a statement of fact, but it does address real problems that science ignores. Qualitative change, the radical differences between scientific disciplines, and the emergence of wholly new entities and systems, from the origin of physical law to the emergence of life and thought itself. The discussion here is necessarily wide-ranging, from holist Buddhist philosophy to the problems and possibilities of high-level abstraction. We start with a tape recording made by Jim Schofield earlier this month, which begins this complex conversation.
What I want to do here is to do with Buddhism, because there was a thing on the internet about an Australian Buddhist who was going to talk about secular Buddhism. Now, to begin with, he spent a lot of time saying why lots of people consider themselves to be secular Buddhists. And what they were really doing was rejecting the kind of spiritual, religious side, but emphasizing the rationality, the logic side. But as he went on, it became clear that he didn't think it was correct. And I think a very important point occurred when he tried to differentiate what real Buddhism is from secular Buddhism. And he embodied the whole thing in the idea of reawakening, which of course is a real thing, there's no doubt about it. It happens in thinking. When you think you know something, you understand something thoroughly, and then you suddenly hit on some extra information which makes it clear that you didn't understand it. And there's another aspect to it which changes a lot. That is a reawakening in thought. But of course, the Buddhists extended that beyond thought. And he made reawakening something else. And the more I listened to his description of reawakening, the more I understood that he didn't know what it was that was going on, even in thinking. Because what it turns out that the real Marxist thinks about reawakening is that you're transcending the current level at which thinking, at which you're considering, because reality is not completely defined by the things within that limited level. It is an example of when things go to a new level, what I call the emergence of the wholly new. Now, he was recognizing that in thinking, but didn't call it that. He called it reawakening. And he made it not just about thinking, but about development too. And of course, that isn't the case. The emergence of the wholly new, which is extremely important in Marxism, right from the very beginnings when Marx was talking about what happened in society when certain things went through various stages and at a certain point transcended everything within that stage and pushed things into a new level with what he called a revolutionary change. A revolutionary change is not seen as such in material things by Buddhists, but by Marxists. It explains both changes in development, concrete changes in real development, as well as changes in our understanding. The two are different. One is a transcending of categories of thought and ideas and thinking, and the other is a real concrete change in the relationships of things in reality, concrete reality. Now, I thought this was a pretty important feature because it's the one thing that I've been working on now for some time, the emergence of the wholly new. And it is a damn nuisance, to put it simply, because if it's wholly new, how do you ever explain it? And if you can't explain it in any way, it's not much good to you. You can only describe it. And that, of course, is what most people do. But here's the thing. As Lenin, not Marx, but Lenin realized, I don't know, 70 years after the beginning of the work by Marx, Lenin noticed that you can actually see this happening, this emergence of the wholly new, by looking at what is produced and studying the new level. And when you do, there are all sorts of new categories, new things there. And if you try to understand them in terms of the level below, you do get explanations. Now, it's a very interesting thing to do that, because it's not, as someone like Dennis Noble, the Oxford Don, would say, top-down causality. It's not that. It is top-down in one sense, but it's also bottom-up. But not bottom-up from the level below. Not from there. You can't do it. It includes its own subordinate levels. When you get a revolutionary change, when you get a change to a wholly new reality, that reality has within it subordinate things that were never even evident in the level below. You could only ever realize them, consider them, do anything with them, once you were aware of the newly emerged level. Now, this is an amazing development. Lenin partly understood it without a doubt, else he wouldn't have been able to get things right and be the great revolutionary leader that he was. But I think its full explanation remains to be done. And when you think about it, the idea that I've been putting forward for some time about a series of levels, multiple levels, thousands of levels, each one on top of the other, with activities happening within them that can be related numerically with physical laws, for example. But if you want to explain things, you have to be able to go between levels. There's no other way. And so it's not top-down in the usual sense, because you have to study the level above that's been revealed by the move to a new level. And only in there, in the details of the new features and characteristics and properties that seem to emerge, can you explain the transition. So it's not a stack of levels, as was the first conception, but a tree structure, almost an up-down tree structure. Because as you move up the levels, you reveal below each new level a lower built-in level. Not the one that you knew about before, but one that can only be studied once you've realized the new level. So as you can imagine, if you go up through all the levels that exist in reality, you will be generating below each its own subordinate lower level, not the one that you knew about before you realized it at all, but one integrated with it. And if you looked into that, you get the same sort of structure. So you get kind of upside down tree. If you were right at the top of this structure and you've got a single thing you want to explain, okay, you actually have to go up and then down to be able to do it. But within the new level, you're not going down to all the levels that you knew about before at all. Each level has its own subordinate levels that you can only realize when you transcend the level itself concretely and with enough information to go further. Now, that wasn't the only thing that's cropped up. It was an important one, and it explains why Buddhism seems to have something to offer. It's offering realization of things in its reawakenings in thought, but it can't explain development. It cannot explain development. Now, also, I was listening today to David Harvey talking about the Grundrisse, a work that was undertaken by Karl Marx before he wrote Capital. And it was well worth listening to him, because what didn't happen in Capital but happens in the Grundrisse is that Marx went into reasons. He went into reasons why things happened, which is not what he does in Capital. And therefore, that was why David Harvey was bothering to study this previous work, because it's very revealing of Marx's method. And you could see that if you only read Capital, for instance, you'd miss many, many of these subordinate built-in levels, which are the only way you'll explain many things. The trick to be able to do any sort of explanation is to go beyond the current level, within which only empirical relationships are immediately available. Explanations are what we need very badly when the wholly new occurs. And that involves a particular kind of interaction at the current level, which we call revolutionary. It in fact kicks things up into a higher level. And once in the higher level, you're in a different world, really. It has different properties and variabilities and so on. But it relates to the underlying level in some way. Now the question is, can we explain these new features in terms of the underlying things that we knew, which were purely numeric? The answer is no, we can't. And in fact, you have to look very, very carefully in the new level and try and get below what you see immediately. Indeed, every new level has a built-in, intrinsic, underlying level. And only there will you be able to relate the variables that you see in this level to causes. You will not find them in the level below. Now, this is not generally understood, but it was, in fact, what was used for a century by physicists, because they went to another science, chemistry, where they found out properties of substances. And these properties and the sub-level that was intrinsic to that new higher level would give you what you require. You were not explaining the new things in terms of the ones in the level below. You couldn't. They were purely numeric. You had to go to an intrinsic, built-in sub-level to the new level, and then you could do it. Now, it was never explained as such at school. It was all science, right? And things found in chemistry could be used in physics. And that's effectively what teachers did. Now, in doing so, they did us all a favour. Because if you stuck like glue to the original level only, you'd never explain anything. Purely numeric. Couldn't do it. So you had to generate the new level and then investigate its own subordinate sub-level in order to be able to do the explanation. And that is the only way. It is in fact the only way throughout reality. New qualities emerge in new levels, and their explanations will not be found in the old qualities that generated them, but in subordinate levels of the new level. Now, this is true of everything, really. So when you go through all sorts of investigations, be it physics, chemistry, biology, or anything higher, you're always having to go to a new level and find its subordinate levels in order to explain things. This is a very, very important feature which was not even realized in school. So when physicists went to university and started doing physics seriously, they were restricted to the level they were working in. And all they could find were these empirical laws. Each level at its immediate form would only give you empirical relations. You had to dig a lot deeper into a subordinate part of every level to be able to explain things. Now, this immediately says, well, is the first level that we investigate in physics the bottommost level? Is it? And the answer is no. We think it is. We assume it is. But it is in fact not so. And the proof is that there are certain qualities, even in the bottommost level in physics, which can't be explained. The most important being sign, positive and negative. They seem to be just given in what is assumed to be the base level in physics. But no, they are qualities which must be explained somehow, and you can't explain them purely in terms of those numeric-only possibilities. We now have explained sign. Just to prove my point, we can go on to life, and there's another one there that seems to come out of nowhere: sex. Where does that come from? When we look at a given level in life and we find male and female, can we explain where they come from? The answer is no, we can't. You'd have to go into a subordinate level, and there you might find something which helps. But generally, it is correct to say that this structure of levels, basic levels and then subordinate levels, is not understood, usually. Not at all. And so I was very, very disappointed in what they would call in physics at university.
Perhaps the thing that has to be made very clear when we're talking about these matters is what we term possibility spaces. Because when you're trying to explain anything, you don't always explain it concretely. You have to have things that you talk about, define, name, and so on. And when you later on try and explain that to somebody, they may say, what is everything there? And the trouble is, you see, they're all ideas. They're all descriptions that can then be used in explanations. So we have to make it clear that we call those things a relevant possibility space. And of course, they'll all happen in a real space. So they cannot be confused. Now, what needed to be gone into is the fact that there are many levels in an explanation which are not necessarily evident, hidden. And when we are trying to explain two things, one in terms of another, you can get difficulties because those two things, the thing to be explained and the thing to explain it, are in different possibility spaces. They're not directly relating to one another. And the way that we've explained these things so far is to say that rather than being able to make such an explanation, we usually have to define the latter, the upper possibility space, and then investigate its possibilities. Because it's only in that sub-level, which is part of the new uh, target level, that you will get the explanation. And that can be hidden very easily. And yet they're all possibility spaces. They're not real spaces. So what we've got to do, I think, in all these descriptions is make it clear what these hidden spaces are. All possibility spaces, but without them, we can't make explanations. And in fact, it's surprising that you can get people trying to explain things across boundaries, which are really gulfs between them. And what they're doing is they're not explaining, they're describing what happens. And that's no good. That doesn't tell you anything, really. It's just saying when this happens, that happens. The whole point about an explanation is it says why something happens. And that will be made clear only by certain things being identified in the target area, which are not in the area you're trying to explain, or at least its effects in the target area.
I mean, I think the conversation on possibility spaces and how they might map or how they don't map onto real spaces, and the fact that we need these to get a grasp on anything really talks back to the previous work that you've done and that we've published on Shape on abstraction. Because I think all of these things, the possibility spaces we're talking about, the notion of levels and the importance of reality being constructed of levels, all of these things are ways of looking at reality that have what you'd call objective content. They have truth in them, but they're still abstractions. They're probably very necessary abstractions. And it seems to me that the most important thing for us to do as scientists, as philosophers, that scientists often forget to do, is to be mindful of the fact that they are abstractions and not confuse them with reality, or not to build on them as if they're reality. Would you say that's a fair assessment?
Oh yeah, that's true. It's the trouble is, every time we try and explain something, we're going beyond the immediately evident. We're saying, oh, that's just happened. Why? And you can't make a very quick and easy answer to that. So what you do is you look for something that seems to be important and might have an effect. But for that thing to have an effect, you have to say more about it. You have to go into its properties, and maybe the properties of several different things, and then try and bring them together to form an explanation. So every explanation is full of those sort of things. They're not full descriptions. You're not taking a finished object and using it to produce another finished object. You're taking features of one thing, but then able to explain the occurrence of another.
Yeah, I mean, I think one of the big differences between Marxism and Buddhism, which we've mentioned, and traditional scientific methods, is that the former are happy to use and also acknowledge the fact that they simplify, that they use metaphors, that they use analogies, that we were reliant on constructs. And science seems to forget that. And actually, as long as we're mindful of the fact that we're making abstractions in order to understand things, then we're less likely to get misled and to end up in ideality, in spaces that basically we've constructed that we then mistake for reality. So do you think that's the key thing to this new philosophical approach? Is that how we stop ourselves getting misled?
I think so. I think as long as we constantly make it clear that what we're doing is working in a possibility space, because that's going to make it easier for us to find answers. But that it isn't a description of reality as is, it's an abstraction from reality, simplified sufficiently to enable us to be able to explain why this happens or that happens and so on.
So let's take the main possibility space under discussion today, which is the idea that reality is constructed of levels. To what degree would you say this does map onto a real space? Is it, I mean, I guess it has to some degree, otherwise it wouldn't be a useful way of looking at things.
Yes, the trouble is it can map all together too well, can't it?
Yeah.
I mean, if you're talking about something in a real space, but you're trying to explain something, you're going to do the usual abstractions to try and find the important parts that will enable you to explain something. But they will be from the possibility space of what's there, what the properties are of the things there, and what the significant properties are. Not all the properties are necessary, but some will be. And you will take those out and you'll relate them to make an explanation. But you are dealing in a chosen possibility space. You're not actually using the whole of a concrete space. And they can be very easily confused when the thing that you're trying to describe is in a real space.
I mean, that's, I guess, when we're talking about levels, that real space is probably to do with scale, isn't it? I mean, you know, there really are really tiny things that operate in a completely different physical level of reality to us, and then to, you know, solar systems, star systems, galaxies. I mean, they are physical spaces that we can observe at different scales, but that's not the full story about levels, is it?
No, indeed. In fact, if you got too bound up with all the actual levels, all the actual possibility levels that exist in a certain space, you wouldn't explain anything. You've got to select from the ones that are there and pick the ones that are relevant. So it's very, very important that you differentiate these possibilities from the real space. The real space will have thousands of things in it, but you don't need all those thousands of things. You need certain ones that are relevant to what you're trying to explain.
And I guess this is where abstractions always come in, because what abstraction allows you to do is select from a highly diverse and incredibly complex real space that you encounter, and decide what's salient, and decide what's going to be an agent for change, or what's going to be the thing that allows you to understand in a deeper way what's going on. And that's why we abstract. If we didn't abstract from reality, which is always a form of selection, we'd be constantly lost, wouldn't we? Because there's just too much going on.
No doubt about that. And of course, what we always do anyway, no matter how hard we try, is that we will take certain things and use them because they seem to be easy to use to explain something. And it may be just wrong. It may be a mistake. One of the things you have to do is not only choose what you want to take from reality as an abstraction, as a set of features, properties, but you've also got to check that you haven't kidded yourself, because it's fairly easy to get an explanation out of this particular set. Quite frankly, That happens a lot.
So we're in most disciplines we're probably using some form of abstraction in order to get a handle on things. Philosophers do it, scientists do it, Marxists do it. What's different about the way that we're doing it than, say, a scientist extracting data from a certain situation, or abstract, or using high-level, highly abstract mathematics, for example?
Oh, well, the latter's easy to answer, the abstract mathematics, because mathematics is not real in the real space sense. It's always an abstraction. Mathematics is always an abstraction. It depends what you measure. It depends what you weigh, and how you see them relating to one another. So certainly mathematics is not the essence of a real situation, which some people think it is. It is just what we're talking about here, a particular kind of possibility space and abstraction that can in fact be very misleading, particularly if the people involved are mathematicians and they know very, very large numbers of relations that they've seen in the past in many different areas, and they bring them to bear in this area because they think it's likely that they'll be relevant, because they might not be. Don't trust mathematics as your primary source of a possibility space.
So how do we then check that our possibility spaces are reflecting something real, that they have enough objective content? Because whether we're using mathematics or whether we're using extended metaphors, we still have the possibility of going too far away from something material and objective. So what do we need to do to make sure that we're not creating a fantasy
land? We have to
land?
set ourselves more than one task to explain. It's not that you need all of these explanations. It's that in getting various explanations of the same sort of materials to explain different things, you will sort out which are the ones that really matter and which ones don't. You've got to use it beyond the thing you're trying to explain in order to make sure it's relevant.
So yeah, I mean, I guess that's a fundamental difference, because a lot of things in science and technology, they have a very specific domain of applicability beyond which it ceases to work. And so what they've managed to abstract there works in that very specific context, and they see that as proof that it's true. Whereas I think a holistic proof that something's true is that it works outside of your domain of applicability.
That's right. Absolutely correct. You've got to give it that test, the holistic test, or else what you've done is you've planted an explanation in inverted commas on it. It may not be the explanation at all. You've got to have means of testing the very things that you're using to see if they're valid in this context.
Is that how we might find out more about these levels that you were talking about earlier, then? The new idea that when a new level of reality is created in an emergent situation, it's not that it's built on lower levels, it's that it somehow transforms the lower levels below it, or creates a subset of lower levels below it, which are its key ingredients. Because this is a new idea, isn't it, in emergence theory and in this idea of levels?
It's so new an idea that, that there's a lot of mistakes made.
Yeah.
There really are a lot of mistakes. And not only that, in my experience as a physicist, lots of things that are supposed to have been explained and were explained to me in my education have turned out later to be invalid.
Yeah.
And the reason is that things have been transferred from being legitimate in one situation to another where they weren't legitimate. It's so easy to make abstractions and think that they're absolutes, whereas they're always context dependent, every single one of them.
It's an interesting, because I think, a lot of Marxists talk about contingency, that it's about certain situations being in the right time, the right place, the right things are there for things to happen, that we can't make generalities beyond that because things are always contingent on the context. But then you've also got Hegel saying to generalize is to think. I think it's the quote. But I guess you've got to generalize and be mindful of your generalization, haven't you?
That's right.
You have to generalize, but at the same time you have to know that will fail at some point.
The big task now, this may seem a bit meandering what we're talking about, but the main task is to try and explain these levels that there are that we originally are unaware of. There's so many of them that we're not aware of, where you think, what causes that? And you have no idea. And you find out that for long periods of time, it's just been assumed to be a feature of reality as is, without any explanation. And if you do that too much, you're not explaining anything. You're describing, and that's not good enough.
I mean, I think the interesting thing about these new ideas is they're almost a generalization about generalizations, which is anti-generalizing, which is quite a contradictory sort of Marxist stance to take, really. But I mean, one of the things that we were talking, because it's all very new stuff, this, so we're still wrapping our heads around it. But the this idea that a new level might, in a way, farm the levels below it as a subset is really. I wrote this down earlier when I was listening to the first part of this issue, and I thought maybe that's why science gets away with doing the same thing. Because we always talk about how in scientific experiments we have to farm a piece of reality, this domain of applicability, where we're making a piece of reality fit, and so we get consistent results, and so that the laws always apply.
The tail wags the dog.
But maybe one of the things that's always flummoxed me about this is that how has science and particularly technology managed to get away with it for so long? But perhaps it's because it reflects something about the way reality is organized anyway, which is this idea that a new level can have these mini top-down effects where it almost farms the levels below it, or changes the levels below it, or creates a new set of subordinate levels below it. In a way, is a level farming reality in the same way that science does.
It's not an easy area, by no means. But one of the things that has happened to me in my long career, and it is long now, is that I've come to conclusions at various points and written them up, published them, and so on, and then later found them to be incorrect.
Yeah.
And you've got to be aware of that. You can't kind of say that everything I've said in the past I can depend upon completely and wholly, because you might not have had enough information, or you might be simplifying it, or you may be comparing it with something that is inappropriate. It's not easy, especially when so little is known about these levels. There really isn't very little known. The two examples I've given in the past are sign in charges, positive and negative, and male and female in sexual characteristics. If you try and use those in all circumstances in exactly the same way, you'll be in trouble. because we don't have explanations. We do not have explanations for those that are generally applicable everywhere.
No, and I think one of the things that we seem to be quite happy to do is just say, well, that's the way it is, and not seek an explanation. And that one about positive and negative charge is just an assumed truism which no one really attempts to explain, and yet there must be a material reason for that. There must be some of these, what you call subordinate levels, below what we assume to be the base level of reality, creating positive and negative charge.
Well, it's interesting because there was a big discussion between two very famous scientists, Richard Dawkins and Dennis Noble, both biologists, and they were disagreeing with each other. They've both written very famous books, and they were disagreeing about causes and so on. And what was interesting about it is that each in their own era were revolutionaries and were making new things available to people, to the world. But they were from different eras, the two scientists. And it was evident that that in those different eras, they came to conclusions that were very different indeed. And in the end, when they were fighting against each other with their assumptions of what were the causes for things, they both ended up more or less admitting they didn't really know.
Yeah.
And so they picked something that was just being revealed by various people in science and says, well, that's tiny enough to be in both contexts, and maybe that is a bottom-up explanation of what we're trying to do here. And that is a very, very common thing that happens in science. Very common.
The other common thing that happens, not just in science, but I think in the academic world in general, is that people never really want to admit that they've been wrong in the past. That it might somehow undermine their work. Whereas I think, you have to admit. I mean, you can't expect to get everything right the first time, and you have to build certain constructs and certain ideas, see parts of them fail to work out where the truth is. So, I think that's a real limitation in academia, that people aren't willing to almost admit their mistakes and go, actually, I was wrong about that. This is why I was wrong about that. And this is where we're going next. Because
the truth is that nobody's explanation about anything is the whole truth.
Yeah.
We just don't know enough. We haven't dug deep enough. We haven't gone far enough. So, whatever your explanation is, it may suffice for now. But why do any of them ever suffice? Do you know what the reason is? Production. If science is to understand reality as is, it'll be one thing. If science is to be able to make things that we need and work as we hope they will, that's another. If production is the thing that determines truth, you'll get one set of things. And if constant attempts to find the truth is to be it, you'll get other things. And it'll change all the time as more and more levels are revealed. There's no such thing as the absolute truth about anything. They're all attempts at a certain time and a certain level of knowledge.